Hello skating community, Will Rudolph here once again to educate you on the technology of the wonderful sport of figure skating. Skaters have always asked, which blade should I choose? The majority of the time, a skater uses what their coach uses, and the coach is on that blade because that's what their coach used. In this extensive video, we will show you what advancements have been made to increase the performance of figure skate blades. First, what changes in the manufacturing of blades have been made? Does the pick design really impact skating performance? What types of metal are the blades made of? What are the differences in values between these different types of metals? And finally, the significance of blade weight, strength, accuracy, consistency, and how these higher quality of metals are going to increase a skater's performance. The most common blades were developed in the 1930s and are still used today. Here we show how they are made. Plates cut out of steel and simply welded together. In order to keep the metal from warping, brazing and low temperature silver solder is used. Here you can see the brazing. The plates here are unattached. After brazing, the blades are chrome plated to protect the carbon steel from rusting. Paramount blades are made from a one-piece T-shaped extrusion. Here's a Paramount blade partially made. You can see how it's made from one piece, which is much stronger than silver solder or brazing pieces together. Here's a Jackson Matrix blade. Here's another with a cutaway view. You can see how the blade is hollow inside with thin areas and weak points. Jackson blades use threaded screws. The problem with using a screw is there is tolerance between the very small threaded screw and the hole. With constant jumping and pounding, these small treads break down, become loose, causing a clicking noise and falling out of the blade onto the ice. These small screws that blend in with the ice will result in other skaters falling, getting injured, and causing them to lose their competition. To help with this flaw design, skaters should always be checking their blades, making sure there are no missing screws. Wilson MK has always marketed their blades on toe picks. People ask, what type of pick should I choose? Which pick is better? The pick digs down into the ice and stops movement. If the blade slips and doesn't grab the ice, there's a loss of performance. The fact is, with all designs, small, large, dull, and sharp, they all perform the same task. If none of the pick designs slip, then why is so much emphasis being placed on them? Gracie Gold uses the Pattern 99 pick design. Evan Lysacek uses both the Gold Seal and the Pattern 99. And Patrick Chan uses the Phantom. People say the pick needs to be big. Well, here's a Gold Seal. It is a small pick, just like the Majestic. Next, I will discuss the different metals used throughout the industry and how a skater's performance is impacted by the weight, stiffness, accuracy, and consistency of these different metals. Paramount uses three types of metal: 440C stainless steel, 420HC stainless steel, and 1085 carbon. These metals are made with different components, which greatly affect the cost of the metals. Wilson Skate Blade Company originally made swords, going back 600 years. Carbon is a component used to make the metal hard, so the more carbon added, the harder the metal. In the 1950s and 1960s, new types of metals were developed that improve wear. This is what causes a skate blade or knife to become dull. When skating along for hundreds of miles on the ice, small particles wear away due to impurities in the ice, causing the sharp metal edge to become dull. New types of components such as chromium, molybdenum, and vanadium were added to these metals to create more tightly bonded molecules that in turn keep the edges sharp longer. When people ask the hardness of the blade, this is not the only determining factor of keeping the edges sharp. People must look at the wear characteristics of the blade also. In other words, not only how hard the metal is, but how much metal is taken off the blade. Here's a photo of this test being done. Testing of the wear is done using sand being fed by a tube into a spinning wheel, which grinds against the metal. How much metal is worn away over time determines the wear. The Paramount 440C has 8 components with the highest carbon content, 0.95% to 1.2% carbon, 16 to 18% chromium, and 0.75 molybdenum at a cost of $10 per pound. The Paramount 420HC has 0.50% nickel, 0.45% carbon, and 13% chromium at a cost of $7 per pound. Wilson traditional blades use 1075 carbon steel, which is missing all these valuable components. The cost of the traditional metal is 89 cents a pound. That is less than 1/10 of the price of the 440C. Jackson Matrix uses AUS, a Japanese grade comparable to the 420HC. Rydell blades do not list the types of steel used, only that they are made in Sweden. We only found 2 companies that produce this type of stainless steel. Wilson's design to create their lightweight Revolution blade involves having a plastic sole and heel plate along with making the blade thinner. Here is a pattern 99. And here is a Phantom. Now we will measure the Revolution. 70% of the weight saved is accomplished by making the blades thinner and not the plastic sole and heel plates. The disadvantage to making the blade thinner is that it makes the blade weaker and allows the blade to bend. Now we will weigh the Paramount stainless steel blade, the Paramount carbon blade, and the Rydell titanium blade. Rydell claims their titanium blades are the lightest. How they save weight is by making the blades smaller and lower to the ice, which requires a transition in skating. If we compare the Paramount with the titanium Pinnacle blade, the Paramount is 2 grams lighter. Next, we will compare the Jackson Matrix and the Paramount stainless steel blade. With the Jackson Matrix, the main loss of weight on these blades is by making the blades thinner. Next, we will weigh a traditional steel blade, the Wilson Revolution, and a Paramount stainless steel. Wilson's design to create their lightweight Revolution blade involves having a plastic sole and heel plate, along with making the blade thinner. Finally, we will talk about blade flex. If a blade flexes, the skater loses power transfer to the ice. The Wilson MK Revolution blade is much stiffer than the normal steel blade. The reason for this is there is more metal in the middle of the blade. Rydell talks about titanium being 3 times stronger than aluminum, but the titanium flexes 3 times more than a traditional steel blade with the same thickness. The aluminum is not as strong as titanium, but the Paramount blades are 3 times thicker, which makes them the stiffest, strongest, and most accurate blades in the industry. If we compare, Paramount uses better material, is made with higher precision, and is a stiffer blade, allowing more power being transferred to the ice. Paramount is the lightest, stiffest, strongest, consistent, and most accurate blade in the market.